evaluate the integral. We got integral of a fraction with square root of x squared minus 25 on the top and x cubed on the bottom. When we have a quotient, we first try for u substitution, and our u would be the inside function, inside radical sign. And when we do the derivative, that's 2x. We can always manage 2. We need x on the top. Unfortunately, we got x cubed on the bottom. In general, when we have a fraction, we try to assume u equals something from the bottom, but that's not the case here. In fact, u substitution does not work. It's much more complicated. But luckily, this is square root of something function square minus u square form. Then when we have under radical sign or some power, inside function is u square minus a square form, where u in this case is x and a is a number, then we can integrate using Trig substitution. For that, we need to use u equals a secant theta. And when we plug this in inside here, we're going to use secant square minus 1 equals tangent square theta, this identity. Then we can get rid of this square root. Okay, so this substitution makes possible to get rid of this square root. So in this particular question, x squared means u is x, 25 means 5 squared, so a is 5. So we let x, u equals a secant theta, means x equals 5 secant theta. Find derivatives of both sides, dx over d theta. I'm going to write on the other side. Derivative of 5 secant theta is 5 times derivative of secant is secant tangent. Then this integral becomes, we got, let's work out this with this substitution so that I don't have to copy everything. Here, square root of x squared minus 25 on the top. Okay, x squared minus 25, that is in this particular case, x is 5 secant theta. So 5 secant theta, quantity is squared. 5 squared means 25 secant squared theta. And we have minus 25. Inside radical sign, we can factor 25. That leaves secant squared theta minus 1. Now, secant squared theta minus 1 is tangent squared theta. This is tangent squared theta. Okay, now we can take a square root here. Square root of 25 is times, so it's 5. And this is pretty much tangent square theta when we take square root tangent theta. Okay, so for this integral, square root of x squared minus 25 is pretty much 5 tangent theta. Okay, 5 tangent theta on the top, all over x cubed means 5 secant theta cubed. 5 cubed means 125 secant cube theta times dx, and dx is 5 secant theta tangent theta d theta. Okay, this is dx. Okay, now let's simplify this. Okay, 5 goes 25 times, 5 goes once, 5 goes once, 5 goes 5 times, and secant cube means we got 3 copies of secant on the bottom. Here is one copy cancel, then 2 copies left on the bottom. Tangent, that's on the top, so we need to multiply. So this integral becomes on the top tangent squared theta. Okay, on the bottom we got 5, and we cancel 1 copy of secant, so secant squared. Okay, d theta. We can pull 5 outside. It's 1 over 5. Now we got tangent square over 5 secant square. 5 can be pulled secant square. Okay, we still have a fraction. The problem, still have a fraction. This 5 outside, 1 over 5. Now tangent secant. We know that derivative of tangent is secant squared, but we should not have this on the bottom. When we have tangent square times secant square, then this is u equals tangent, and derivative of tangent is secant square. That would be du. But we have secant square on the bottom, then it does not work. How about writing everything in terms of sine cosine? That might help, because tangent is sine over cosine, secant is 1 over cosine. Oh, then cosine on the bottom, we can cancel. So on the top, tangent is sine over cosine. That means sine square over cosine, all over secant square is 1 over cosine. Okay, and if we simplify this complex fraction, we keep change division into multiplication, flip, this secant square goes on the top, so we can cancel right away. Oh, that makes simpler now. 1 over 5 times just sine square theta. And by the way, antiderivative of sine square is not negative cosine square. For square it does not work. Whenever we have sine square or cosine square, then we need to use the half angle formula. What is that? Sine square theta is 1/2 1 minus cosine 2 theta. And we can integrate this right hand side easily. With a square, there is no rule. So this is 1/5 integral of this formula 1/2 1 minus cosine 2 theta. Okay, now we are able to integrate. This times 1/2 we can pull outside, 2 on the bottom, so 2 times 5, 10. So this is 1 over 10. Now antiderivative of 1 is x, but our variable is theta, minus antiderivative of cosine, because we got two terms, we need to integrate each. Antiderivative of cosine is sine 2 theta, but there is a 2, so we need to divide by 2. And plus c, you can write inside or outside, does not matter. Okay, we are done. Now we need to go back and write this answer in terms of x, because this is given in terms of theta, but our question is in terms of x. So using this first assumption, what we did here, x equals 5 secant theta, we need to draw a right triangle so that each trig function can be written in terms of x. So x equals 5 secant theta, so that's what we're going to use here. So x equals 5 secant theta, that is same as divide by 5, so x equals 5 equals secant theta. Okay, so write in this way, secant is reciprocal of cosine. Okay, so secant theta is x equals 5, means we can write cosine, more familiar function, just reciprocal 5 over x. Based on this, we have a right triangle. Cosine is adjacent over hypotenuse. Okay, adjacent over hypotenuse. So this is 5 over x. And by the Pythagorean theorem, a square plus b square equals c square. This is b. A square plus b square equals c square. So 5 squared 25 plus b squared equals x squared. And now subtract 25 from both sides. Okay, then x squared minus 25. So b squared equals x squared minus 25. Take a square root. So b equals square root of x squared minus 25. So this side opposite is pretty much square root of x squared minus 25. Okay, this is not x minus 5. You cannot take a square root. Now with all the sides of this triangle, we can go back and plug in. Unfortunately, we have sine 2 theta here. We have angle theta for the triangle. So sine 2 theta should be reduced in terms of theta. And we need to use double angle formula. Sine 2 theta is 2 sine theta times cosine theta, another identity. So this is 1 over 10. By the way, theta, you can write from here by here or here, doesn't matter which one. Let's use cosine. Cosine theta is 5 over x. That means theta equals, take cosine inverse of both sides, cosine inverse 5 over x. Or we could have used this as well. In this case, theta would be secant inverse of x over 5. So these are equivalent. So from this, so I'm going to write this. So this theta is in fact cosine inverse of 5 over x minus sine 2 theta is 2 sine theta cosine theta all over 2 plus c, and here we can cancel 2 from top and bottom. Sine theta times cosine theta, we find their values using this triangle. So 1 over 10, so this is the last step, cosine inverse of 5 over x minus sine theta. Sine is opposite over hypotenuse. So square root of x squared minus 25 over x times cosine theta, which is adjacent over hypotenuse, 5 over x. We cannot multiply inside and outside of square root, but x times x is x squared. That's just minor. I'm going to leave here plus c is the final answer. Okay, final.